Well, thank you, Jeremy, for the kind introduction. I am really thrilled to be here today for the first time at Black Alps. I want to thank you all for coming to our talk, and I also want to thank the Black Alp organizers for giving us this opportunity. Very often when you have conversations around security, they're about how security is becoming increasingly more complex and also increasingly more real time. You have to react faster and faster to incidents, vulnerabilities, and so forth. This talk is not about that. It's about how security is a slow process, particularly when you think about younger companies that are still forming and growing. It takes time to develop a security program. And sometimes it feels like there is a mismatch of expectations. Small companies come up, have services, they have end users and data, and there is this expectation that they're suddenly Fort Knox. And it's not the case. It takes a while to build a good program. So it feels a little bit like there is a taboo subject around discussing security for smaller companies. And really the idea here is that no matter which type of companies you're working at or you will work at, these kinds of conversations help us all think about security and sort of how do we reason about working in security for growing companies. So the agenda is basically, I'll introduce very briefly myself and our team, and then we'll talk about building security at a growing company, at a young company. A little bit how you don't start in ideal situations, how the evolution of a security program sometimes is not predictable, and also cloud computing. I often hear people ask me, oh, so you're using the cloud, why do you need a security team? I honestly still get a lot of these questions, and it makes no sense. And while cloud computing can be your friend, it also can also introduce some difficulties. So we'll give some examples on that. And then we'll conclude by sharing a few lessons we learned along the way. So our team, first, my name is Jad Boutros, and I'm the CISO at Snap. I joined Snap about 3.5 years ago. At the time, it was a company of fewer than 50 employees total. Today, our team alone is bigger than 50. And so I was hired to start an information security team. And now, essentially, we own 3 different areas at Snap. We own all of security. We also own privacy engineering, and we own spam and abuse. So we're responsible for these 3 areas. And it's somewhat a unique situation. It's not that often that, for instance, spam and abuse and security and privacy are all under one roof. But for us, we found that to be absolutely thrilling. It gave us abilities to implement more efficient solutions and to establish more effective processes with the rest of the company that have less overhead, but also that are more exciting, because we tend to all think about all these considerations as one team and advise one single solution to the rest of the company for how to do things. Another aspect that is unique to our team is that we do a lot of development. So we own mission critical areas of our app, and that's across sort of mobile, web, backend systems, and you name it. We also build a lot of internal tools that are used by the rest of the company. Snap now uses 2 cloud providers. It's not a secret. We started primarily with Google on Google Cloud, and now we're adding Amazon for some of our services as well. So we basically, as a company, we use any and all technologies from these 2 cloud providers. And we have a very high scale sort of production environment with many, many complexities. And it gives us a sense of the challenges that as a big customer of these clouds that we face. And we work very closely with our sort of cloud providers to keep adding new features and improvements for security. I call this talk 0 to 60 in 3 years because it took us about 3 years to reach around 60 engineers on our team. And now we're sort of a little bit above 80 and trending towards 100. We keep growing. So essentially, the first sort of theme is how security doesn't always start in ideal conditions. If you look at security at a young company, you have to realize that for companies that are starting, their first focus isn't usually security. It's first, come up with an idea, develop that idea, launch it, have users, consumers, and customers, and build that. So ship software is the first priority. If you don't do that, you won't survive as a company. So typically when security starts to get involved is when you have a product that is used by genuine end users, and you start thinking about what are the sort of situations that you can get into, or potentially an incident happened and it forces you to think more about it. So security usually starts in a way a little bit behind, and it very much feels like what you're always playing catch up. You're always trying to get above water, and the company is moving sometimes faster than you can react. So even in sort of modern age today, when a company is starting, there's still some serious security challenges that it has to face. And honestly, none of these are completely unsolvable problems. In fact, more mature and larger companies have solved them, but they're very, very difficult. They're challenging, and I sort of make the claim that no small security team can actually solve them without spending a lot of energy and a lot of effort. So one of them is patching, and patching really means many different things. It means sort of patching, your corporate workstations, so that if you get a bad malicious Microsoft Word document and it doesn't completely compromise your machine. It also means patching your production systems, because it's still the case that developers start with a more naive implementation where they have stateful services. And so they build these machines, they hold user data, and those machines can't really go down without causing an outage. So you often find still machines that have been up and running for a year or more, and they haven't been patched. Also, patching can refer to third-party libraries and systems, especially for smaller companies that are growing fast. You have the situation where you have a lot of dependencies on open source software and other software not written by you. And so when you think about patching there, it's not trivial. You have to discover where you use all of these libraries and services, and then you have to be subscribed somehow to get notified that there are critical vulnerabilities and be able to have a process in place to fix them. These are not trivial problems to tackle. Another one is that companies often want to personalize services to their users, so they create this registration and login method. And sometimes they depend on other providers, but more often than not, they want to control username credentials for those users. And the minute they do that, they expose themselves to a lot of very bad things that can happen. You've all seen for the last many years how many troves of password databases have been stolen and released and made public. And so by now, security teams starting this would think about using proper crypto for handling passwords, for example, hashing, key rounds of derivation, and so forth. But also you have to think about rate limits, and those are not trivial. If you don't do that, someone can brute force passwords. And it looks simple, but it's not a very simple problem to have really good rate limits that don't also DOS you out. The other one is, how do you handle password reuse? You know that end users are going to use the same password on many sites. You know that some of these sites are going to get compromised. So you have to deal with a way to reset passwords, recover accounts, even find when these things happen in the first place. And those are not trivial problems. It takes a lot to be able to do them. Another challenge is that usually as companies start, every developer and other administrator has a sort of root equivalent access to systems and user data. So they have the highest privileges, and that works fine when it's a small company because they're all connected and committed to innovating. But as the company keeps scaling, it creates a lot of problems because you want to be able to know who did what mistake was introduced. And the more you give power to a lot more developers, mistakes will happen, and some of them are security mistakes. Sort of the other part is also that, you know, as security programs are built, they don't necessarily follow a very predictable path. And so it is usually the case that for more mature companies, all of those that care deeply about security and privacy end up roughly in the same spot. They end up having a mature security program. How they get there can vary a lot. And particularly when a security team is still small, it can be swayed in ways that it can't necessarily control. And so it could be, for instance, an incident that happened and forces the team to react to it and build a lot more defenses in that space. Or it could also be that business needs change in ways that you didn't anticipate and forces you to get into directions that maybe you didn't plan ahead of time. So really what is important is how do you deal with these situations. What I wanted to sort of briefly touch on is sort of what is a mature security program? I've been saying that word a few times, and sort of not everyone, you can ask reasonable people, they won't exactly agree on what that is, but this is a good way to look at it, sort of having a set of pillars that drive your security program, and all of these pillars are strong. Combined, you will get a more mature security program. So, for instance, you want safe products for your end users so that their data isn't stolen. To do that, you may do security by design, follow security by design principles, do security reviews, think about fuzzing, pen testing, sandboxing, you name it. But essentially, you want that when you release software, they're safe. You also want to have a strong infrastructure, because if your infrastructure is exposed to outside threats or even insider threats, it will jeopardize your own products. And so you want to have strong corporate systems and networks. You also want to have strong source code handling and build and deployment systems. You want to have vulnerability management, because you've seen recently with the Equifax breach that it was sort of attributed to Apache Struts not being patched when a vulnerability came up. You don't want to be in a situation where you have some vulnerability that you may know about and you forget to deploy it properly, to deploy a patch for it properly. Incident response is because, let's say you have an incident, you don't want to make it even worse than what it is, right? You want to give a chance to your end users to recover from a potential incident. For instance, telling them to reset passwords before that they are revealed to the outside world. You don't want to be in a situation where you only find out 3 years later that something bad happened, and then there is no chance for your end users to recover from the breach. Vendor management is very important, particularly for younger companies that have more of these vendor dependencies. If you want to understand what risk vendors introduce to your own security posture, particularly for things where they have access to user data or sensitive systems. Acquisitions are also very interesting. You know, as companies grow, they may acquire other companies to complement their product offering. And so what's the point of you having a very mature security program, but an acquisition comes up and has a very, very amateurish one, and then you're sharing user data with that acquisition. You're suddenly exposing your data to risks that you don't want to deal with. Education and awareness, really important. Your employees need to know. what are the bad things that could happen on the internet, and there are many, many of them, and also what are the good ways to do certain things. For example, for phishing, not everybody knows what phishing looks like. If you don't do phishing training and phishing exercises, they won't know how to detect them and avoid them. And then as a company grows and your security team grows, more and more you will demand that the company starts to integrate security into their workflows and processes. And so there is a bigger cost when you ask them to do things that turn out not to be strictly necessary. You want to be able to focus on the risks that are the most important to the company. And so that's where governance and risk management and understanding that really matters a lot. So to give you sort of a little bit of anecdotes on evolution, I wanted to mention a timeline. It's an incomplete timeline, but one that shows a little bit in our experience at Snap with us building a security team, how we could be swayed sometimes in directions that we don't necessarily predict ahead of time. So I started in April 2014. I was the first security person. And for the first 2 months, I was very, very focused on application security, reviewing all our code on mobile, web, and backends, and make sure there are no vulnerabilities that are exposed. And then this was working very well, and 2 months later, we had a major spam issue. And it got noticed very quickly within the company, even to our own employees. They started to see unwanted friend additions, for instance. And we knew right away, we set up a war room, and we knew we had to investigate it and stop it as quickly as possible. Now, in the course of doing that, we realized that our spam and abuse defenses aren't necessarily where we'd like them to be. So once we saw how bad things can be from that day, we spent a lot of time focusing on spam and abuse, building stronger defenses, understanding better what things are, logging more issues around spam. And we almost stopped any work on security to be able to address the threats that were present and strong. And so we focused on that and moved our attention. Then in October of that year, there was a third-party app, not at all affiliated with Snapchat, but it asked users to give them their Snapchat usernames and passwords so that this app could then interact with Snapchat servers on behalf of those users. And one of these apps got compromised, and it was found that they were storing snaps, even though they didn't tell their end users that they were storing them. So those snaps, essentially images and videos, were disclosed to the internet. And when that happened, we had a choice. We said we could do nothing, because our terms of service clearly state that our end users should not be giving their usernames and passwords to apps that are not affiliated with us. Or we could decide to understand how this happened and try to put defenses to make sure that no other app can reverse engineer our mobile APIs and then use them in manners that we didn't authorize. And so when this thing happened, we decided that's what we're going to do. We're going to double down on preventing other apps from integrating with our ecosystem. And I'm mentioning it here because that became a very, very large running effort, actually still growing effort, which actually brought us as well to Switzerland. So we're very excited about that. And a project that is sort of one of a kind for social networks. I don't think other networks, social networks, had to deal with these kinds of situations, but we decided to take the situation and handle it the best way we could and move into territories we didn't necessarily expect. A month later, Snapchat at the time released Snapcash, which is a way for end users to make payment on our app. At the time, we were a little bit edgy. Why do we want to introduce payment? It has more attack surface, more things that can go wrong. And so we decided to work very closely with our partners to build a payment protocol that addressed some of the things we were worried about. And that was also a business need that came that we didn't necessarily predict it would come so early in our stage. and it swayed us to work on the weaknesses that we were worried about. In 2015, we made public our vulnerability rewards program. It's been a wonderful, wonderful program that connects us a lot with the security community. But at the time, we were still a very small team, and we didn't know whether it would kill us or not. We actually had no idea whether we would be spending the next 6 months, day and night, dealing with findings that come our way. Fortunately, while we had sort of findings that were all very low severity for the most part, and we were able to tackle them well. Then in February of 2016, we had a case where an employee fell for a phishing situation and disclosed certain employee data outside the company. And that was also an event we didn't necessarily know that it would happen, but when it happened, we had already been building a lot of phishing defenses, and we accelerated. We went a lot deeper into building anti-phishing defenses. We used, for example, security keys for all of our two-factor authentication. We built a lot of detection into emails and all of that. So we tried to take this situation and leverage it and defend against it for the future the best way we could. Throughout the evolution of Snap, we've been acquiring companies, but in the past we were able to shut down potentially the services that we were acquiring until they ported back to Snap code base and systems. But this year we acquired more companies where we wanted to keep their services up. And this was a huge tax for our security team, because now suddenly not only do we have to deal with our security, but also security of companies that didn't necessarily have security and privacy presence. So we spent a lot of our energy dealing with that. And it may put us into a path that we built a lot more services that we can make available to acquisitions, and we spent considerable energy dealing with them. So this is sort of on how how evolution of security teams can be sometimes unpredictable, but at the end it helps make us more and more mature. The third part that I wanted to talk about with building security teams is cloud computing. So I'm going to share just a few anecdotes. It's by no means complete. And I would say, you know what, this could be a topic of a talk in itself, but actually there is one. I think this afternoon there is a talk dedicated to security for cloud computing. So the part about sort of cloud computing to realize is that it affects pretty much every pillar of a security program. Cloud computing is absolutely wonderful for innovation and for allowing a company to get to market much more quickly. But also cloud is a very young company of its own. It's been evolving incredibly over the last few years. And as it grows more and more complex, it definitely has enough rope for us to hang ourselves. So we have to be very careful with how we deal with cloud technologies. And sort of to see that, I want to talk a little bit about perimeter with the cloud. So if we look at a simplified production environment that is a traditional one, not a cloud one, you sort of see that clients are connecting through the internet to your production systems, but the first thing they hit is a firewall. Everything is running behind a firewall. You have your web server or your mobile servers, API endpoints, and so forth. They're behind a firewall. Your database is definitely behind a firewall, potentially multiple firewalls. It's usually the most protected part. So in this environment, you have potentially your network engineer opening up ports on the firewall when you want to expose services to the internet. And your developers are potentially changing web servers and deploying software on them. So this is of course, I'm simplifying. There's a lot of internal tools and VPN access for administrators that aren't represented here. But we'll contrast this with how it is in a cloud environment. In the cloud environment, you still also have content from the internet coming through a firewall that potentially you control or is managed by your cloud provider, and your web services and databases behind it. But you also have a lot more that is directly exposed to the internet. You could have managed web servers that aren't depicted here, but you have your database is directly reachable from the outside. All you need is potentially an API key to connect to it. You could have many different forms of databases, managed databases. You can have Cloud SQL instances. You can have cloud storage like Google Cloud Storage or S3 on Amazon. You also have your cloud management console that allows you to do very, very powerful administrative tasks. All of these are directly exposed to the internet. So the other thing is that with cloud computing, your network engineers have shrunk usually because you rely a lot more on network controls given by the cloud provider. So what does this really mean? It means perimeter becomes very interesting on the cloud. Sort of one of the key tenets of security is you want to have a minimal exposed attack surface to the outside world. So how do you do that when you have so many technologies that are directly reachable? And another part of that is that now you have more and more developers who also have the ability to change firewall rules. And we'll talk more about why that is later in this talk. So some of the things that we've been tackling with these issues, and we built some solutions toward that. For instance, locking down SSH on all the virtual machines so that they go through gateways that we designate. We also built web proxies that are authenticating so that any tools and web servers, applications, web apps that we build ourselves for our own internal needs, they're still protected by a layer of defense in front. And also because we can't necessarily restrict all the developers from changing firewall rules, we built a lot of monitoring around them so that we get alerts, and based on severity of those changes, we can automatically roll back firewall changes. Another sort of anecdote is around identity and access management, IAM. So that part has changed drastically in the few years that we've been using cloud. For instance, we were on Google Cloud 100% before, and there were only 3 access roles that Google Cloud supported. You could be viewer, editor, or owner of a project. And the least powerful one is viewer, and that one allows you to see all the contents of all your databases and your cloud storage and everything else. So even that least powerful one is incredibly powerful. Now today, cloud providers support a lot richer IAM policies. So you can have a lot more fine-grained controls. But still, they're not fine-grained enough to meet our needs, for instance. To give you one example, we want developers to be able to access content in our databases that is not sensitive, but content that is user content that we deem sensitive, we don't want them to access it. So we can't give them roles that just flat out let them access all the contents of a database. So what we ended up doing is taking the cloud provider tools that let you access databases and replace them with our own that provide our own layer of authentication on top so we can restrict what tables you're accessing. And that's a lot of work. We also built permissioning tools because, for instance, on Google Cloud, we have 700 different environments. And so to be able to view who has access to what on 700 different environments, it's a major pain to do. So we built this sort of permissioning tool that lets you see who has access to what across all of those projects, and also to grant access to fine-grained roles and have an approval process to grant such access when it's needed. We also made it time-based, so we can grant access for 1 hour if we wanted to, and then it just automatically expires. Another area we've been dabbling with as well is sort of the risk that we lose our information so that it's exfiltrated somewhere that doesn't belong to us. And that's also a real problem in the cloud. If you go back to a traditional sort of production environment, it's very hard to siphon data off. Now, you could have vulnerabilities and that could still happen, of course, but more likely than not, to be able to get through to the outside, it has to go through some sort of external firewall or NAT device, and you can do monitoring in place there. But in the cloud, you can't really do that. So how do you detect when, for instance, someone accidentally copies a bucket, a cloud storage bucket, to a different company that doesn't belong to us? How do you discover that buckets aren't made world readable or viewable by accident? And for the last few years, we've seen a lot of companies have user data compromised because they were put on cloud storage that had wrong permissions. So we spent a lot of time working with our cloud providers to have access to logs so we can see when there is a copy in progress, and we can shut it down in real time when we think it's not going to our own environment. We also built a lot of alerting around changes to our buckets so that if something gets opened and it hasn't received the right approvals, we stop it and roll it back right away. So there are a lot more sort of anecdotes with cloud around visibility, around many other challenges with taming it so that it doesn't introduce unsafe ways for us to be innovating and operating with. But I just wanted to kind of give a sneak preview of some of the areas that we've been tackling. So now that we looked a little bit at about how we start sort of potentially a step later than security ideally would be, and how sort of the evolution isn't necessarily deterministic ahead of time, and that cloud can introduce its own challenges. What have we really learned from all of that ourselves? So one of the things we learned is the value of building a good, a solid security team. We find that, and we see this a lot when we're interviewing candidates. They come in from a company where they're the only security person, and you know it's doomed to fail. You know that it's going to be incredibly frustrating for them to handle any and all security needs, and it's not going to be a win-win situation for the company either. So sort of avoid being the only one as a general rule. It's almost better not to have security team than to have just one person. But for us, we went with a rule of thumb that actually our boss created when I started, which is we want security to be roughly 10% of engineering. Now, you can argue why is it based on the size of your engineering team? Why not other factors? And there are many, many different ways you can sort of figure out a ballpark figure for how big a security team should be. But just looking at this very simple one, 10% of engineering, helps us see how we are evolving over time and whether we are growing as fast as we should be, or whether we're sort of being left behind. The other thing is that there are really multiplicative effects of having a larger team. And so on one side, it gives us a more healthy mix of operational and hardening work. Because operational work in security can come in many, many different shapes. Sort of investigating malware on workstations, doing security reviews for new features and products, doing privacy reviews, handling abuse situations. All of these are a cost, essentially an operational cost that we have to accept every single day. But if that cost overpowers a team, then there is no way that that team can keep growing its security program. So when a team is larger, it can more parallelize, deal with operational issues, and also keep improving its own maturity. It also obviously makes for a happier environment because you don't feel as frustrated constantly with having to say no to the business all the time because you don't have time to work with them on specific functionality that they need. Also, because it allows us to do a lot more interesting work. And for us, some examples of that work are My Eyes Only, which is a feature that is part of Memories on Snapchat. It's a way where an end user can save their snaps to our servers indefinitely, but also do that safely in a way that our company can't access the content. So in a way, it's kind of like an end-to-end system, end-to-end encryption system, where the end user is both ends of that system. End user uploads contents, keeps it, saves it on our systems. It's encrypted using fairly advanced crypto, but also relying on a PIN or a passphrase, and a passphrase can be very long to deal well with brute forcing. And essentially upload that content and save it with more confidence that that content can only be viewed by them. We think we're the first large social network who did something like this. It has a drawback outside of security that if you forget your long passphrase and you chose a long passphrase, your content is lost. But that was a decision that the business was okay with. So it allowed us wiggle room to come up with a very interesting protocol here that involved many different components within our Snap systems, so that even in the case of a partial compromise of our production systems, we could still keep your data safe. It also allowed us to take over authentication, for instance. So authentication of end users on the Snapchat app, authentication of our ads partners, authentication of our publisher content, single sign-on solutions for web, for mobile, and so forth. And those we couldn't have done if we were a smaller team. So we have this feeling of we're able to do things that are enabling good innovation, but in a safer way. And also it allowed us to do some very cutting edge work in privacy. So this year we've been tipping our toes in differential privacy, and also in ability to do machine learning and model training on clients, so that we send less data to our servers, so that Snap has less data on you that can potentially be disclosed where something bad were to happen. So the third part sort of value of building a larger team is you can be a better partner to engineering. And that's really extremely important. You don't want to be the team that keeps saying no. You want to be a team that tries to work with other engineering teams to come up with really cool innovations. And the only way you can do that is by having the capacity to take on such projects. Another part that is interesting is, when you reach a certain maturity level and you go through certifications and you can tell the world we have a mature security program, it's easy to understand how you fare with respect to expectations. But when you're a smaller team at a young company that is still growing, what is normal is actually very difficult to get, because at that point you don't yet have a mature security program. So how do you evaluate whether what you're doing is in the right direction, whether you're meeting all expectations, or whether you need to hire and grow faster, for instance? Also for us, there's always this feeling that you're always behind, right? You start a step later in the company's evolution, and you're always playing to catch up when the company is really very focused on growing and innovating. So for us, we kind of asked ourselves a number of questions. One of them is, how many times do we say no, right? I mean, as a security team, you have to say no very often. But you also know that the more you do that, the more you're stifling innovation. So how often do you say it? Do you track how often you do that? And is that trending upwards, which is bad, or trending downwards, which means you're doing a lot more, you're being able to enable more than you did before? Also for security incidents, are they spiraling out of control, or are they going at a reasonable pace? If they're spiraling out of control, you need to hire more and grow faster. And also asking feedback from other stakeholders in the company. What do they tell you when they interact with your security team? Do they feel like you're a good partner, or do they have constructive feedback to give? So for us, this is kind of what it felt to figure out what is normal as we were growing. Sort of the last lesson for us really is about security as a culture, because no matter how big and capable a security team is, it really can do almost nothing if it doesn't have support from the rest of the company. This support is critical. You cannot be in a corner on your own, developing, doing your own thing. and not interacting and working and collaborating with the rest of the company. So sort of our advice, our experience is that we want to focus a lot on building the right partnerships. We do a lot more together with the rest of the company when we are aligned and we are working in the same direction. So for us, it was more about communicating our roadmap more accurately to the rest of the company, to all the key stakeholders, so that we align roadmaps over the coming year. For instance, we've been doing this exercise now for 2018, and it helps us build those, define the projects and collaborations we want to do next year with all the engineering teams. We also want to share updates on a regular basis so that others know what we're working on, what is important to us, and how they can help us with it. As much as it's difficult, we want to share postmortems as well, because that's the way we learn about mistakes that happen. When something bad happens, we learn from it, we share this learning. So always communicating. And I think last part is really staying calm, because it's very easy to be frustrated when you're working in security, and it helps no one. It doesn't help you, it eats you alive, and it doesn't help the company. So staying calm and enjoying the process. I think I want to really say thank you very much, and I hope you enjoy the conference, and we'll be here, so I look forward to a lot more discussions. Thank you.
Wait, sorry. We have 5 minutes for questions, if Yard want to answer it, of course. So, has anyone has a question? Sure, Christian, yeah.
I'll go with one. Thank you.
If you can share the mic.
Yeah, we'll share. Thanks for a very interesting talk. You mentioned your vulnerability or bug bounty program. Bug bounty program is something very un-Swiss to do. There are only like a handful of bug bounty programs I know of in Switzerland. Could you elaborate a bit how you do that and why it works for you?
Well, thank you. And sorry I left without questions. I didn't know there would be any. So look, there are ways a bug bounty program can definitely backfire. There's no doubt about it. If you start thinking of it in terms of outsourcing your security to the rest of the world, you're doing it wrong. This is not a good way to improve security over time. However, if it helps you connect with the security community, it's really a wonderful thing. We organize some events we host our rewards program on HackerOne, and we organized some events where they flew in all their researchers for 24 hours to try to break into our app. We even spent a month preparing for it to remove some of our defenses and make it more possible for them to find bugs in our app. And we thought, this is amazing. We want to be able to find really meaningful bugs and get them reported to us and be able to deal with them and improve based on them. Without this financial sort of incentive, there are fewer people who will look for security bugs in your app. I mean, why would they look in your app when there are many others that offer, for instance, much higher amounts? So it's also about trying to incentivize without going necessarily crazy with prices, but and incentivize the right sort of types of bugs that you're interested in. So for example, we are, of course, extremely interested with remote code execution, be it on the client or on the server. So those we would pay a lot more for. And even if it's something that is partial towards that, we would find it very valuable. Honestly, for us, given we were committed to responding in time to security researchers, we were committed to try to improve our security posture, the posture of our app. And also because we have a lot of acquisitions, and those acquisitions, they're going to get attacked. So we much prefer to know about it from the security research community, be able to recognize that there is an issue and tackle it ahead rather than it becoming an incident. We found it very, very valuable. Thank you. Yes.
Have compliance or legal requirements had any impact in your progress?
Thank you. This is a great question. So I mentioned that we are responsible for privacy engineering, and the reason I didn't say privacy is because for us at Snap, privacy works as a very strong collaboration between our team, privacy engineering, and the legal team, which is privacy on the legal side. This has been the beginning, the defining part of our privacy program. Anything that happens at Snap has to be reviewed for privacy, and usually it's by our team and legal as well. So we work extremely closely with the legal team. And as a result of that, we're able to factor in their considerations very smoothly over time. And so there hasn't really been anything that we completely didn't expect. For instance, the hot topic right now is GDPR, and it's something we've been thinking about and working with legal team for a very long time on. And we feel that we're working to the point where we're going to be ready with all the right expectations way before the deadline kicks in. Compliance is definitely extremely important. We actually have an arm of our security team that deals with security compliance. And the reason it's part of our team is that we feel compliance should be at the table as we're designing our defenses for all sorts of things. It shouldn't come as an afterthought. Build it from the beginning, have that consideration weigh in on the design in the first place so that you achieve the right win-win situations, smooth compliance, as well as designs that withstand the right kind of scrutiny. And we think a lot about compliance. We partner a lot with different partners for ads and other purposes, and they have a lot of needs from us in terms of how we protect their data. So compliance is definitely something we take very seriously.
So I fear we don't have any more time for questions, but you see Snap has a really nice tone on the main floor. So yeah, go and talk to them. So I would really like to thank you, Jad, for being so transparent. I'm convinced that we as a security community, we will only make real progress if people start to share what happens. So I really enjoyed what you told us. Thanks a lot, Jad.
Thank you very much.